So, hello everyone. I am Lucie PERIN, PhD student at AgroParisTech. Thank you for watching this video where I will present my PhD work entitled Assessment of Intensification Potential and Sustainability of Ruminant Farming Practices at the Global Scale. So firstly, I would like to present my PhD work in a few sentences. So I work on the impact assessment of various ruminant farming from over the world. I am currently in my second year of PhD at AgroParisTech, and I am based at CIRED, so a research center on environment and development based in Nogent-sur-Marne, close to Paris. And my PhD thesis is funded by Sealand. So I am part of the Challenge 3 of Sealand, which is understanding and managing the transition towards integrated land management. So a few words of my background. So I obtained a bachelor in bioengineering from the Free University of Brussels in Belgium, as well as a master in agronomy in 2016. Then I had a couple years of working mainly as a consultant for various organizations. And I started this PhD thesis in October 2019. And my thesis is supervised by Patrice Dumas. So now I will present my PhD work. So its context, its objectives, and also the framework. So I am working on ruminant farming, which is a ubiquitous activity worldwide. It's characterized by a strong diversity in production methods and practices with contrasted biophysical characteristic and also very diverse production objectives. So some production can have the income generation objective or the possession of working capital, for example. There is also a lot of diversities of species, of breeds, and also of products, such as, of course, meat and milk, but also manure, draw power, calves for meat production, etc. So this diversity of systems imply to have very diverse environmental impacts, as well as economic and social performances. So among environmental impacts, we can name a few of the main ones. For example, the use of natural resources by ruminant production, greenhouse gases emissions, water pollution coming mainly from inadequate manure management, biodiversity impacts, some positive, some negative, mainly from indirect sources such as deforestation, greenhouse gases emissions, water pollution, etc. So concerning economic performances, so these diverse systems have, of course, diverse profits depending on their production, on animal production. And in addition to the financial income from the sales of products, some systems also provide many co-benefits, such as drought power, working capital, fertility transfer. So all of that depending on resources availability, of course, but also on farming practices. And we should also not forget the social performances, such as sometimes a very strong cultural dimension, the autonomy, the diversification of these different systems. So the first main objective of this PhD thesis is to define various ruminant farming systems from over the world. And the method used is to create a typology, which is based on literature review. It's also based on existing typologies and also, of course, on some experts' knowledge. The second main objective of this PhD is to assess their economic and environmental impacts. And to reach that goal, we will model the typology created before in order to assess their impacts and be able to compare them. So I will first explain how we define these various forming systems. So as I said, the method proposed is the typology. So we have built a typology as well as a framework for the evaluation of environmental impacts of what we call management types. So this typology is based on these three concepts that you can see, the management type, the phase, and the lineage group. So firstly, the typology distinguishes various management types here in green, in the green bubble, that are defined by a set of production methods and farming practices, and which is also partly based on existing typology. Each management type is characterized by various criteria, such as the type of diet, herd management and mobility, pasture management and intensity, land integration, farming objective. So we distinguish in farming objective the objective of production compared to the objective of possessing a working capital. Also manure management and farming outcome, for example, milk or meat. So the typology is really based on these management types. Now, we figured that one animal could spend its entire life in the same management type or change during its life. And to be able to follow these movements, we subdivided the life of an animal into different phases. So a phase corresponds to a specific age, sex, function, geographical localization, and also specific feed duration of an animal. And finally, we have the lineage group. This is described as animals coming from the same origin, so meaning, for example, having the same mother, and also having the same management type destinations, meaning that when animals are moving throughout their life, they are part of the same lineage group if they end up in the same destination, management type destination. So here, as a little example, we can really see here the division of the life of an animal into various phases, which allows us to better trace its movement across management type and really follow the animal. So here we can really see that according, for example, if the calf is a female or a male, we have various options. And also we can see that animals can easily either stay in their management type of origin or change and go somewhere else and still belong to the same lineage group because they have the same origin. So I present here the decision tree that we are using to identify in the end 16 management types. So the criteria used in this decision tree are first the presence of pastures, then herd mobility, so between nomad and sedentary practices. Then we have the integration with agriculture, so either no integration at all or on-farm cropping. The presence of trees, to not forget some systems that are partly based on trees. The feed diet, very important also. The outcome, so we differentiate between dairy, for D for dairy and M for meat. And the production objective, so between P for a productive objective, so meaning the wish to sell products and have income, compared to C, having a working capital. The herd is seen as a kind of an insurance and a working capital. And finally, all these management types are divided into E and I. So E for extensive pastures management and I for intensive pasture management. So here are the 16 management types that we identified thanks to the criteria and the decision tree presented before. Now, the second part of my PhD thesis is to model the management types as well as the lineage groups identified previously. So the objective of this model is really to compare lineage groups based on either their private economic performance alone, or also on their socio-environmental impacts combined with the economic performances. So the model can be seen as a three-step process. So the model is done at the grid cell level and with the year as our temporal factor. So step one aims at representing and model each phase of each management type based on the typology that I described before. Step two will model lineage groups and determine how phases are grouped together in lineage groups. And finally, step three will analyze and calculate the performances of lineage groups, including the environmental impacts. So step one so represents every management types and therefore every phase from the typology. So we use various modules that you can see here to model this management type and obtain a spatially explicit model. So we have several sources for data for each of these modules. And sometimes we also base ourselves on already existing models for that part, such as, for example, the pasture management module here in green. We base ourselves partly on the ORCID GM continental model. The objective of step two is to model lineage groups and also link phases together and know where these phases are taking place. So first, about modeling the different lineage groups. So to understand a little bit better, to be able to model lineage groups, our goal is to understand the links between phases. Hence, we want to understand the movements of animal, and so what we call the herd dynamic or the herd structure. So here, as an example, we have a cow that can have either a female calf or a male calf. So the female calf will most likely become a heifer and then a cow and participate to the herd renewal. But the cow can also have a male calf that will potentially enter then a fattening phase after weaning, either by exiting the farm of birth or by staying in the origin farm. So this same herd belongs to a management type that here we call a management type A. And every male calf from this management type A can either be sent to another management type for the fattening phase and enter the young bovine phase, or stay in its management type of origin to be fattened and then be sent to slaughter. So the difference between the two young bovines here that you see, one in management type A and one in the B, when they arrive at slaughter could potentially be, for example, the age, the weight of the carcass, the country, etc. So part of management type A, that includes the cow, her male descendant, belongs to one lineage group, here called lineage group 1. Whereas management type B, that includes the young bovine coming from management type A, added to the cow because it's his mother, forms another lineage group. So there are here two different lineage groups, as the management type of destination for the young bovine is different, even if they have the same origin. And finally, about phases, location of and grouping. For that, we calculate the net profits of each potential destination phase location, and we compare them to then choose the destination phase location with the maximum profit. And then finally, step 3, which is about performances calculations of each lineage group. So one option to calculate the performance of a lineage group is to calculate, for example, the greenhouse gases emissions per farming outcomes, so meaning per products, and then perform an economic allocation. So we identified 5 main products from, 6 main products from ruminant farming. So we have milk, meat, but we also added manure, finance, which is working capital, insurance, and drought power. So to identify the greenhouse gases emissions of one lineage group, we perform an economic allocation for each of these products. So as a conclusion, this work can have various perspectives for the future. Could be the start for various work. So, for example, we can think of including variation over time, depending, for example, on land use competition and the change of land use. We can also think of changing in food demand. We know that there are many changes concerning the demand in meat products everywhere in the world. So some parts are reducing their consumption, some parts are increasing it. So that could be one option. We could also include variation over time depending on climate change, etc. And this could, for example, allow us to obtain projections to identify sustainable development path for ruminant farming, depending on the country or the region. So this work, this PhD thesis, could be a base for other studies concerning the typology part. It could also be included in other global models, so more the modeling part, such as, for example, the Nexus land use model. So thank you for watching this video. If you are interested in my work or would like to reach me, it would be a pleasure. And you find here on this slide my email address. Do not hesitate. Thank you very much.